So good morning students, welcome back. Today we'll start differentiation. Before starting third chapter in physics, we have to require differentiation, that is a branch of mathematics, okay, in solving the derivation, in solving the numerical, in various derivation, we require the term differentiation. In order to solve the derivation, to simplify the numerical, okay, we require differentiation, okay. So let's start the differentiation, that is a branch of mathematics. It generally comes in mathematics in 12th class, but in physics it required, okay, for solving numerical and for solving the derivation. So look students, d by dx, that is a form of differentiation, okay. Suppose if you want to differentiate, okay, constant, our first formula is what will be the differentiation of constant d by dx. It means differentiation of constant with respect to x, 0. So the very first form is differentiation of constant is what? 0. Okay, like I will give example, d by dx of 5. 5 is a number, all numbers are constant, so its differentiation will be 0. Suppose you have to differentiate 1000. Again 1000 is a number, that is constant, so differentiation will be what? 0. So our first formula is what? Differentiation of constant will be 0. Okay. Now students, the second form, this is the first formula. Now the second formula is d by dx of x to the power n. That is one of the most important, generally in physics, for solving for numerical, either for that solving derivation. Mostly we'll use this formula, d by dx of x to the power n. So n x to the power n minus 1, n x to the power n minus 1, that is the formula for differentiation of this x to the power n. I will give example. Suppose if you have to differentiate x square, how to differentiate? First of all, write d by dx of x square. Now compare both. Instead n, we are having 2. So 2x power 2 minus 1, n minus 1. Look at, instead n we have 2. So n minus 1, 2 minus 1. Okay. 2 minus 1, 1, and no need to write 1. So what will be the differentiation of x square? 2x. Okay. Suppose you have to differentiate 1 upon x square. First of all, you write d by dx of 1 upon x square. Transfer x square upwards, it become d by dx of x to the power minus 2. Now apply the formula, n x to the power n minus 1. Instead n, this time we are having minus 2. So what will I write, students? Minus 2 x power minus 2 minus 1. Minus 2, minus 1 minus 2, minus 3. And one more term we can extend. On taking downwards, it become minus 2 x power 3. So this will also we can write. So that is one of the most important formula. Okay. Mostly we'll use this formula x to the power n. Okay. Now students, come on that third formula. D by dx of c x to the power n. What is c? C means constant. When constant alone, its differentiation will be what? 0. But whenever the constant comes with some function, in that case, it comes outside, there will be no differentiation of that function, only the x to the power n is differentiable. Okay. When constant alone, its differentiation will be what? 0. But whenever constant comes with some function, it comes outside from differentiation, there will be no differentiation of constant. I'll give example. Suppose the example is this time we have to differentiate 10x power 4. Okay. So we'll write d by dx of 10x to the power 4. Okay students, 10. If d by dx of 10, if 10 is alone, their differentiation will be what? 0. But here 10 comes with this function, that's why it comes outside and will differentiate only x to the power 4. And which formula is applicable? This one. 10 come outside because it is with function x to the power 4. Okay, so we'll write 4x power 4 minus 1 and n minus 1. 10 into 4, 40. 4 minus 1, 3. So this will be the differentiation of 10x power 4. Remember, when constant alone, differentiation 0. When constant come with some function, at that time constant come outside from differentiation, and the remaining function is only differentiate. Okay, students? Now students, next fourth formula, d by dx of sin x. We'll use some trigonometric form also. Okay, for solving purpose of numerical and the derivation, we required some trigonometric form also. So you have to know the meaning of differentiation of sin x, sin theta, cos theta. Differentiation of sin x is what? Cos x. And of reciprocal, differentiate of cos x is what? Minus sin x. Remember the formula? Okay. You can take a screenshot. Differentiation of sin x is what? Cos x. And differentiation of cos x is what? Minus sin x. See one more formula. D by dx of sin ax. So a cos ax. Generally sin x, differentiation of sin x is what? Cos x. So differentiation of sin ax is cos ax, but the constant attached with this function variable comes outside. Okay. Similarly, d by dx of cos ax. We know differential of cos ax is what? Minus sin x. So differential minus sin x, sin ax, and a comes in multiplication. Okay. So I will give you an example on these two formula. So look at the example. Suppose you are asking differentiate sin 8x. Differentiate the sin 8x. How can you differentiate? D by dx of sin 8x. Compare with sin ax. Instead a, we are having 8. Simple. Differentiation of sin x is cos x. So sin x become cos 8x, and a always comes in multiplication. So 8 always comes in multiplication. 8 cos 8x. Understood, students? So this will be the example on this formula. Okay. Now students, you can take a screenshot. These are the formula of differentiation. All these formula will use from 3rd chapter to 12th class, because all these formula of differentiation will directly or indirectly will use in derivation, in numerical, in solving objective question. That we have to know. Okay, so and basically this chapter will come in that mathematics in 12th class. So now students, next is the most important, d by dx of a plus b, a plus minus b. If two components are in plus minus, then d by dx of a plus minus d by dx of b. Both are separately differentiate. Okay. Suppose if you are given, look at, I'll give example on this. D by dx of 4x square plus 10. Okay. So d by dx of 4x square plus d by dx of 10. Look at, 4 is with some function, come outside, and differentiate of x square, 2x power 2 minus 1. N minus 1, I applied that formula. And constant alone, here the 4 is constant but is with some function, that's why it come outside. But here 10 is alone constant, so differentiation will be what? 0. 4 2s are 8. 2 minus 1, 1, no need to write 1, so 8x will be differentiated. So this is an example on this formula. You can take a screenshot. Okay, students? Now students, what happens if two components are in multiplication? D by dx of a into b. In that case, first function as it is, differentiate of second. Then second function as it is, differentiate of first. I will give example on that. Suppose x square dot sin x. You have to differentiate this. Okay. So d by dx of x square dot sin x. This is first function, this is second function. First function as it is, differentiate of second, then second function as it is, differentiate of first. Okay, now students, x square as it is, we know differentiation of sin x, cos x, sin x as it is, and differentiate of x square, 2x power 2 minus 1, 2 minus 1, 1, no need to write 1, basically 2x. So this will be the differentiation. If two components are in multiplication, first as it is differentiate of second, second as it is differentiate of first, and then I solve. Okay students, now students look at, these are 9 to 10 formulas we'll use in derivation. See the last one, d by dx of a by b. If components are division, then b square, b as it is, differentiate of a, minus a as it is, differentiate of b. Okay students, you can check the formula. We are having two components. Okay, now students, I'll give example. D by dx of same x square by sin x by x square. Okay, differentiate b square. Okay, it means x square whole square. Okay students, then b as it is, differentiate of a, differentiate of sin x, minus sin x as it is, differentiate of x square. X square as it is, differentiate of sin x, cos x, sin x as it is, differentiate of 2x, x square, 2x, and that will become x power 4. Okay, so in this way, these formula generally will use for solving purpose of numerical derivation objective question in physics. That's why we did here. Hope so you understood. If you doubts, then tell me. Okay, you can take a screenshot.